So welcome to the 2013 question 6 higher level exam. So toroidal curve BCDEG is the same ellipse. LMN is an identical portion of the same ellipse. Curve BA is a parabola with the vertex B, and GA is an identical parabola with the vertex at G. The lines CG, so CG and EK are tangents to the ellipse. Draw the given design showing clearly all constructions. So we're going to start with the same ellipse BCDEG. Right. It's always a good thing to sketch out what you know about the problem if you're just learning this homework stuff. So concentric circles are drawn on the ellipse. Major circle, okay, minor axis, minor circle, major axis here. So you split up your circles into 60-30, where the division line hits the major circle you go parallel to the minor axis towards the middle, and where the division line hits the minor circle you go parallel to the major axis away from the middle, and they intersect to find points in the ellipse. So that's the concentric circles method. If you have an ellipse, another thing I know about ellipses, if you have the ellipse, okay, the distance from F1 to P plus P to F2, so those two lines added together always equal the major diameter, so the distance between V1 and V2. So if this point was smack bang in the middle, alright, these two blue lines, okay, will be equal to the major diameter, yes, but each blue line will be equal to half the major diameter. So look, I can prove it. Take half the major diameter, swing from it there, see the way they're intersecting there on top of the minor diameter. So if you didn't want to call it half the focal points, you could take half the major and swing from the top of the minor to find them. Now let's look at our question. So we have the major diameter 85, we don't have the minor diameter, and we don't have the focal points, but we do have a point C on the curve, so we're going to work backwards, right? So I'm going to pretend I had a point on the curve here, so point C. So what I would do is I go parallel to the minor axis until it hits the major circle, so I'd work backwards, join back to the centre, and then from C I'd go parallel to the major axis towards the middle until it intersects the sloped line, and then I'd get the point there on the minor circle. So I'll do it again. Okay. I'll draw in my major circle on the question. The major circle has a radius of 85. I go parallel to the minor axis so it hits the major circle, join back to the, that's not the centre point there, join back to the centre point here, so that one there, and then from C go parallel to the major axis. Where they intersect, we have a point on our minor circle, and we can draw it in. So let us begin. So I have my compass, radius 85 for the major circle. So point C is 44 along the centre line and up 36 from the centre line. Up 36, that's point C, and then it's worth marking E, the other side, it's identical, so it's at 72 E. Right, now from C we're going to go parallel to the minor axis towards the major circle. So now, where that hits the major circle, we're going to join that back to the centre, and then from C, we're going to go parallel to the major axis until they intersect. Now, this is a point on the minor circle, so I'm going to take my compass, I'm going to draw in my minor circle, I'm going to divide it up then into 60-30, okay, now where the division lines hit the major circle, we're going to go parallel to the minor. We're going to do it normally now, we're not working backwards, so parallel to the minor towards the middle. So where the division lines hit the major circle, we're going to go parallel to the minor axis towards the middle. Now where the division lines hit the minor circle, we're going to go parallel to the major axis away from the middle. So where the division lines hit the minor circle, we're going to go parallel to the major axis away from the middle. Now this is point C, E, that's B, and that's G. Okay, so here are my points established on the ellipse. I'm going to freehand sketch them in. That's point D. Okay, so there's the points on the ellipse. Right, I'm going to pause and freehand sketch. Right, so that's that marked in. Now, The next bit, curve LM is an identical portion of the same ellipse. So this here is a portion of the ellipse. The reason I've identified, okay, these two is blue, is the width of L to N is 72, and the width of C to E is 72. So it's this portion is going to be pushed down there. Now, how are we going to do that? Right, if you look at the number 36, we need to get points on this quarter here, and to do that, 36 can be evenly divided by 3. So I'm going to divide this evenly into 3 segments. Now, it doesn't have to be 3 segments. It could be 4, 5, 6, 7, 8, 9, 10. I chose 3 because it divided evenly into 36, and it wasn't an excessive amount. Now, so I've marked every 12 along the line, and then down here, I'm going to do the same. I'm going to mark every 12 along the line. I'm going to draw these lines here, and I'm going to put my compass here, take this distance down here, and put it down there. Then this distance here, put it down here. Now, the other side is the exact same. I don't need to do the division up there. I don't need to, because if you marked E in, then it should be the same. So 3 equal divisions, and you plot your first. You can take your first one here, mark it in. Second one, mark it in. Now the question is, just how do you get points L and M? Well, there's a radius 47 circle here, so you draw in a radius 47 circle. It's from the end of the major diameter of the ellipse, so it's 85 from the center. Now you can just mark up 36 along your center line and bring it back, or you can bring C straight back down and E straight back down, and where they pierce the circle are points L and N. So we begin. So marked out 47 here. I'm going to take my compass, draw in my circle. Sorry, I just want to do that again there. So sorry, I marked 47 there from the wrong place. It's just one sec there, I'll rub that out. So I put my compass there accidentally on the end point of the diameter of the vertex rather than the center point. So here's the center point. So we're drawing a circle radius 47. We can bring point C and E down. So that's point L, and then E we can bring down as well. That's point N. Now we're going to divide this, okay, into 3 portions. So 12, 24, 36. I'm going to mark a light line until it punches the ellipse there. So I'm going to leave that 1, 2. Remember there, every 12 apart, those 2 marks. Right, I'm going to do the same down here. So I'm going to mark every 12. Now if you want, you can just bring, instead of marking it again with your set square, you can just bring them back down here, and then I suppose we're going to have to mirror them across, or I'm going to have to mark them in here as I don't have them done. Now I'm going to take my compass, I'm going to take the distance here for 1, mark it there, and 2, here for D, and you can freehand sketch these in. So I'm going to pause and freehand sketch these points for the parabola in. Now, that's that done. Don't know what I was saying a parabola there for. It's an identical portion of the ellipse. So that's L and M. Now, the next part, the parabolas. So B to A. So the parabola B to A. So what we're going to do is use the rectangle method for drawing this in. So we have a line here, parallel to the major axis of the ellipse, a line here from A. Now, so you can divide both sides into any equal number of divisions. 18 is divided evenly by 5, that works out at every, 17, and then 36, I think it works out at every 17. 36 doesn't evenly divide by 5, and segments are quite small, so I think it'd be handiest just to divide by 3, okay, for each side. So to do that, 85 doesn't divide evenly by 3, so I'm going to draw a line at any acute angle. I'm going to mark 3 equal segments along it, so 3 equal segments along it. Okay, I'm going to join the last one back to B, and then all the lines then are parallel afterwards. And then I'm going to do this one. I'm going to draw a line at any acute angle and mark 3 equal segments along it. So I'm going to join this point back, and all the lines are parallel here. Now, these ones here go parallel to the axis perpendicular, the line perpendicular to the axis, they go parallel to the axis. The line parallel to the axis, they go to the vertex. Now, where the first one touches the first one is the point of the parabola, the second one touches the second one, and you sketch in your parabola. Then to get the other side, I can just draw my lines across, okay, put my compass on the center, okay, and just mirror them across. Okay, mirror them across. So that's what can be done. Right, so we'll begin. So we're drawing light line from A here, light line from B. Now, I'm going to divide this line, okay, into 3 equal segments. So I'm going to draw a line at any acute angle. I'm going to mark 3 equal divisions on it. So I'm going to mark what you call it every 20. So 16 to 10. So, and then 2, 4. I'm going to join the last one to B. And then all lines afterwards are parallel. Alright, so to do the parallel lines, I'm going to line the last one up with B. I'm going to put my T-square underneath it, bring my T-square towards my desk. Okay, I'm not going to let my T-square move. So I'm going to slide the line down here, or slide the set square down rather. And there's the points on the edge, and these can draw to the center line and across further for extra work, or to do in a moment's time. So they can. Now I'm going to divide this line up here equally. Okay, so I'm going to draw a line at any acute angle. So any acute angle. I want to mark 3 equal divisions on it. So I'll mark every 20 again. Sorry, I actually went did I? No, never mind. I think what I was going to say. So I'm going to join the last one. I'm going to join the last one here. There, and then I'm going to do the same again. I'm going to hold my T-square underneath the set square, slide it along, slide the set square along with the T-square straight, or the T-square not straight but held steady rather. Now I'm going to join this one to B and this one to B here. It's worth labeling these to avoid confusion. So 1, 2, and this is 1, 2. So where 1 hits 1 is a point in the parabola, and 2 hits 2 is a point in the parabola. So I put them in there. So where 1 hits 1 is a point in the parabola, and 2 hits 2 is a point in the parabola. Then to get the other side, just put my compass there, flip it over, point over, put my compass there, and mark it down further, line, and there's the points in the parabola. So I'm going to freehand sketch them in now. Now, so I've that done, right, so the next thing, the curve C, or the line CG and EK are tangents to the ellipse. Okay, so to draw a tangent to an ellipse from a point on the curve, you need the focal points. Okay, now we don't have the focal points, so what we would do is take half the major and swing from the top of the minor. So you take half the major, okay, and swing from the top of the minor to get the focal points. And then what you would do is you would join the focal point to C, and C to the second focal point, and you would take your compass, bisect the angle, now this is the normal here, and then the tangent makes a right angle with the normal, so you'd use your set square. So we're going to do that. We're going to take half the major and swing from the top of the minor. Okay, so we took half the major axis and swung from the top of the minor to find the focal points. And the reason that works is because F1 to any point on the curve, that line plus the same point back to F2, the two lines equal the major diameter. So if your point B is smack bang in the middle, F1 to B and B to F2 are equal to the major diameter, and one line is half the major. Okay, now, so I'll just clarify on that again. You take half the major diameter, swing from B, okay, left and right. So that's F1, that's F2. Now, we're going to join F1 to C. So F1 to C. So I'm going to do it in pen here. I'll switch to pink to make it easier. C to F2. I'm going to get a compass. I'm going to bisect that angle there. So I'm going to take my compass, set it to any radius, swing an arc on both branches or arms of the angle. Move your compass to both arcs. Don't change the radius. Swing this arc here, this arc here, and then this is your normal here. So that's your normal. Take your T-square, put your T-square underneath your set square, Okay, and then it doesn't have to be tight against or completely against the desk. We're just doing sliding set squares. Slide your set square down, okay, to C. So the line there, and it stops. J is, see that 18mm from the center and line up. So that's point J there. So I'll show you now. I'll put the protractor back. That's the compass. Visualize it back rather. So slow it down. Drew the line in there. I had marked 18 over, drew a line parallel to the minor axis. Where they intersected was point J. Now, same idea for point E. Okay, so take your set square, join E to F2, E to F1. If you're tight for a time, you could just mirror point J over. So you could. I'm pretty sure that'll get you the marks. Take your compass, swing your arcs. So bisect your angle. Sorry, that's not point E. And point E was there a tiny bit there, so I'm going to just do that again. So there's your normal. Drawing your line there. So that's point, what's called K. And then the two circles are radius 18. One's tangential to the center. So here's one of the circles. Then the other one is right here underneath C. Now, that's the question done. I'm going to pause this and heavy it in with black pen to me. So that's what it looks like there. When it's done, I just kind of sketched over the lines and pen there to make it easier to see. And then on your, I know it's a bit late, but you could do the light lines a tad lighter, just in your exam to make it a bit easier for you. I do them a little bit. Add in notes then, and then you're done. Cheers, thanks, bye bye.